So, my dear friends, meeting again for tutorial number 24, and in the series of distance protection of transmission lines, it is number 12. As such, we have completed the theory portion. These two tutorials, number 12 and 13, will be on numericals. How to set the relays, how to set the distance relays. And we have already discussed that it is easier to set the distance relays. It is easier to find the setting of distance relays than overcurrent relays, because we have to think of only locally. That means distance relay measures local voltage and local current. It has nothing to do on source side. So it becomes easier. But however, we should know how to decide the setting of distance relays. And as we have seen, all the distance relays are usually seeing in three zones, Z1, Z2, and Z3, or setting we are telling K1, K2, and K3. K1 is the setting of first zone, K2 is the setting of second zone, K3 is the setting of third zone. In secondary ohms. Secondary ohms means as seen by relay, because primary ohms is different, secondary ohms is different. So that is all what we have to do, and we have to see. So let us start seeing. The application example reads like this: that decide the three zone settings for more distance relay R. We are using more usually. We are yet not going for quadrilateral, etc. I mean, we are not going to the complicated examples. We are going for simple numericals. So we are using more distance relay, and it is universal also. Usually more is very highly universal. So three zone setting of more distance relay are having a characteristic angle 60°. Figure is given. 220 kV lines, the data is given 0.015 plus J 0.09 ohms per kilometer per phase. Line length is 200 kilometer. These are two parallel lines, 220 kV L1 and L2. Third line is 132 kV after the transformers. Impedance is 0.02 plus J 0.08 ohms per kilometer per phase. You can see that X by R ratio has changed. X by R ratio for 220 kV lines is roughly 6. For 132 kV lines, it is 4. Line length is 100 km for 132 kV line. CT ratio for the relay is 1000 bar 1, and PT that connects the relay is 220 kV by 110 volt. First zone covers 80% of line L2, that is given to you. Second zone reaches up to bus C, and accordingly you have to find the setting. And third zone covers the full line L3, so that it can give backup to, I mean, second zone in the second line, 132 kV line, whatever the distance relay is, that has to be backed up by our relay R. So it has to cover full length of that line. So accordingly, we have to find the settings K1, K2, and K3. We have to find the settings K1, K2, and K3 in terms of secondary ohms. So this is the figure, 220 kV lines, the data I told you, 132 kV line after the two transformers, data is given. Then it goes to 132 by 66 kV substation. Right? 3 generators are there which are feeding the parallel lines. Other lines 220 kV are also going from there. But one relay R, that is protecting line L2, we have to find out the setting of relay R in 3 zones. So if you see line L2, relay R covers 80% of line L2 in first zone. In second zone, it reaches up to bus C. That means it covers the it covers both the transformers. Both the transformers are in parallel, and you have to find out the impedance in ohms, because our relay, we have to find out the impedance in ohms, but it is given per unit 10% for both the transformer, each transformer. 132 kV line, the data is given. Now we have to understand that how we are treating this, how we are converting from Z primary to Z secondary. So Z primary is Vp divided by Ip, simple, Ohm's law. Primary side voltage upon primary side current. Z secondary is equal to Vs divided by Is, that is in secondary. So Z secondary divided by Z primary, if you do, then it is Vs divided by Is into Ip divided by Vp. Or in other ways, it is Ip by Is upon Vp by Vs. Something like this. So finally, it is CTR by PTR, CT ratio upon PT ratio. So Z secondary is equal to Z primary times CTR by PTR. Or if you want to do it reverse, if you want to find out Z primary and Z secondary is given, then Z primary is equal to PTR divided by CTR times Z secondary. So that we will see in the next example. So ZL2 is equal to 200 kilometers length and 0.015 plus J 0.9. So it is 3 plus J 18. Converting into polar form, 18.24 angle, 80.53 degree. CTR divided by PTR common, because every time we will have to use this. That is 1000 bar 1 is the CT and 220 kV. So 220 into 10 raised to 3 divided by 110. If you calculate, that comes out to 0.5. So every time you have to convert primary to secondary, you have to multiply by 0.5. That you have to remember. Very, very simple, you see. It's just very simple. Therefore, ZL2 secondary is 9.12. I have to see ZL2 primary was 18.24. It is just to be multiplied by 0.5, so 9.12. So zone 1 reach is what? 80% of this. It is given. So it is 7.296, angle remains the same, 80.53. So what is K1? So for that, one reference is given of the figure, because you see how you can find out K1, because K1 is the diameter of Mohs circle and Z1 is the impedance of the line that we want to protect. So you have to refer this figure, Mohs circle. K1 is the diameter, Z1 is the line impedance, and K1 is the diameter. Therefore, if you complete the triangle, it is a right angle triangle. So Z1 is equal to K1 times cos phi minus theta, or reverse, K1 is equal to Z1 divided by cos phi minus theta, and that is what is done. Z1 is equal to K1 equal to Z1 divided by cos phi minus theta. Now please remember this, that cos phi minus theta, how did we reach to cos phi minus theta? Phi is the angle Z1, right? Phi is the angle of line, transmission line to be protected, and theta is the characteristic angle, designed angle of the relay, and that is 60 degree given. Phi is equal to what? We have found out 80.53. We have already found out. Phi is equal to 80.53 is found out, right? So if you see, K1 is equal to 7.296 divided by 80.53 minus 60. So 7.79 ohms. So we have found out 7. So this you have to set in the relay. That's all. So now the relay will protect up to 80% of line L2. Simple. Very, very, very simple. Then if you want to find out K2, then you will have to add the impedance of the transformer. Impedance of one transformer is kV square by MVA. This is the formula for converting per unit to ohms. So kV square by MVA into X per unit is equal to 220 square by 100 0.1, so 48.4 ohms. And because two transformers are in parallel, combination is 24.2. So zone 2 reach is 3 plus J18. That is the full line length L2 plus J24.2, because it is only J transformer. We are ignoring the resistance because it is reactance is about 50 times the resistance. So 3 plus J 42.2, and if you convert it into polar form, 42.3 angle 85.93. So angle has changed now. Therefore, zone 2 setting, and then that 42.3, when you convert in secondary, it is half that, right? So 21.15. And if you find out K2, 21.15 upon cos phi minus theta, phi 85.93 and theta 60, then it comes out to be 23.517. So do this setting and the relay will reach up to the transformers. Now when you go for zone 3, it says that it will cover full line length ZL3. So 3 plus J18 plus J24.2 is there, plus ZL3 you have to add, that is true. But ZL3 is 132 kV line and relay is on 220 kV side. So ZL3 ohmic rating has to be converted to the relay voltage. Relay voltage is 220 kV. So 220 by 132 square of ZL3. And if you, ZL3 is given 0.02 plus J 0.08. So 2 plus J 0.8. So Z3, third zone relay will see in third zone 3 plus J18 plus J24.2, 220 by 132 square, 2 plus J8. And if you see, that comes out to be 32.49 angle 82.44. Angle once again differs because you see the reactance values are differing. Therefore, zone 3 setting is Z3 by cos phi minus theta. Phi is here 82.44. So it is 35.15. So if you do 35.15, if you set like that, that setting is there in the relay. In relay, there are dials to set any ohmic value. So you set that ohmic value and relay will see up to the 132 kV line. It will cover 132 kV line, 132 kV line fully. So if you see overall, the method is so simple to find out the relay settings. Method is very simple. So this was a simple example, not very difficult. You can easily find out the setting of any relay like this. So with this sentence, I would want to add that when you love as if the person is God, not less than that. If you want to love anybody, love him or her as he or she is God, as you are loving God. Because nobody is less than God. Everybody is God. सब में भगवत्ता छुपी हुई है. Everywhere, everybody is having godliness. So never love a woman as a woman and never love man as a man. Love them as their gods. That is what Osho Rajneesh used to tell. With this sentence, I would end my talk today, remembering Adapt Me, because Adapt Me has given a chance to all of us to meet on this platform to learn power system protection. I am trying my level best to teach the principles of power system protection. You also must be using this chance. But all the way, please share you make a use of this. You read, you hear the video, you understand the power system protection, but share also. I'm also trying to share. I'm also sharing to you. You share with others so that the name of AdaptMe reaches every corner of the world. Thank you, friends, and good day.